Hey U9, welcome to lesson 3 for this week. To start off with, again, 10 quick questions for today's lesson. Something different, can you go to that website, that link, you did this the other week. It's an interactive version. Go through, fill in your answers, click check answers at the end, take a screenshot and include that as part of your work for this week. Alright, U9, thanks for doing those 10 quick questions. Today we're going to look at finding an angle again in today's lesson. This lesson is going to be, the video is going to be a little bit longer. I'm going to run through 2 examples only, and it's all going to be in the one video here. So let's just jump straight into it, shall we? Alright, so example 1 here, we have a picture of a person, we have some kind of bird flying in the air, and the question asks us, at what angle does this man need to look up at to see the bird? And please round your answer to the nearest degree. Okay, no worries. So as always, let's go through and identify all our information. Our hypotenuse, the side opposite our right angle triangle, nothing. So our hypotenuse, nothing. What's our reference angle? Well, our reference angle, we've been asked to find it, so our reference angle is theta. The opposite side, so on the other side of the triangle to our reference angle, is 30, and that leaves 23 as the adjacent side. So thinking back to SOHCAHTOA, so remembering SOHCAHTOA, which one of those deals with the opposite and the adjacent, and that would be tangent. So we have tan of theta is equal to the opposite over the adjacent. Substitute our information in. So tan of theta, our opposite side is 30, and our adjacent side was 23. Remembering now at this stage, we need to use that shift tan on our calculator to find the size of the angle. So theta is going to equal shift tan of 30 over 23. Pulling out our calculator, shift tan of 30 over 23, remembering to close our brackets, and we get 52.52 blah blah blah, which when I round to the nearest degree becomes 53 degrees. Right, so for this question, what we'd like, because it asks what angle does the man need to look at, let's just write a quick sentence. The man needs to look up at 53 degrees. And there we have it. We've answered our question. Example 2 is a little bit different. A ladder of length 311 centimeters needs to make an angle with the wall between 10 and 20 degrees for it to be safe to stand on. And here we have a little bit of a diagram, but it's not really clear that there's a triangle there. So let's draw in this triangle. So what I have is I have the ladder. It comes out from the wall, and the wall is going to meet the ground at right angles, and the ladder forms our hypotenuse. So there is our triangle that we have in the diagram. And the important thing here that I think we need to read here, make an angle with the wall. Now the angle with the wall is this angle up here. Now that's a bit messy to look at, all squished in there. So let's draw that triangle out bigger. We have 311 centimeters there, and we have an angle there. And it's important to remember this 10 and 20 degrees. That angle needs to be between 10 and 20 for it to be safe to stand on. If it's anything different than that, it becomes unsafe. Moving on, the question asks, if the ladder is 100 centimeters away from the wall, is it safe to stand on? So away from the wall, we're talking about the base of the ladder. So we're talking about, is this here? If our ladder made that triangle, is it safe to stand on? So what we need to do is we need to find the size of that angle and say yes, it's safe, or no, it's not. So moving on, we've got our triangle. Same thing as always now. It now just becomes a normal triangle question, finding our angle. Our hypotenuse is 311. Our reference angle is theta. Our opposite side is 100. And there's no adjacent side. Remembering from SOHCAHTOA what deals with opposite and hypotenuse, that's sine. So sine of theta is equal to opposite over hypotenuse. Substituting in our information, sine of theta is equal to 100 over 311. Remember, now we use shift sine to find our answer. So theta equals shift sine of 100 over 311. Let's put that on our calculator, and that is equal to 18.756 blah 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 degrees. Now again, we haven't answered the question yet. The question says it needs to be between 10 and 20 degrees for it to be safe to stand on. The question was, is it safe to stand on? Theta equals 18, well, hang on. It's going to equal 19 degrees when we round to the nearest whole number. So, yes, between 10 and 20. Therefore, it is safe to stand on. Alright, so in summary, we want to look for the triangle in the description or the problem that we have. We want to identify that information. And then, same as all the other times, substitute that information into SOHCAHTOA. Use the shift sine, shift cosine, shift tangent on our calculator and check any rounding. Alright, your work for this lesson. So the 10 quick questions, you've done them earlier by going to that website. You need to go to Cambridge, exercise 4H, follow the links in the weekly planner, questions 7, 8, 10 and 11. If you feel up for it and you want to stretch your understanding of what's happening here with some of these questions, have a go at questions 12 and 13 as well. And as always, correct your work from the solutions, fix any errors that you might have made, take a photo and submit it all to Canvas.